for their navigation. And that means that if you can convincingly fake a GPS signal, you can fool a UAV into tracking your signal instead of the authentic one. And at that point, you can control the UAV. You can make it move left or right, front or back, up or down. In other words, you've hijacked the UAV, and you can do this from miles away. My friends at the University of Texas have prepared a video that I'd like to show you, which illustrates what we did and helps me to explain the technique involved. You see against the background here a UAV, an animated one, like the one we used, flying above the desert floor. This white person entering your picture is the good guy. He's the UAV's remote operator, and he's now uploading to the UAV a waypoint. That white diamond is a destination the UAV is supposed to move to. The GPS satellites above help the UAV locate itself, and as you can see here, it recognizes where it is, where the destination is, and makes its tracks toward the destination, lining up nicely with its goal. But the bad guy moving in here from the left is a spoofer operator, and he's going to transmit fake GPS signals to the UAV. At this point, we'll pause so that I can talk a little bit about what you see on the screen. The peak you see on the screen exists in every GPS receiver. It corresponds to the authentic signals. And you can go ahead and roll it now. But if you can create fake GPS signals, you cause another peak to appear, and that peak, when it lines up with the authentic one, ends up hijacking the tracking loops inside the GPS receiver. And what you'll notice is that as it draws off the tracking loops, a ghost UAV slides out the back. That ghost UAV is where now the UAV thinks it is. It's not its actual location, it's its perceived location. And as it moves toward its waypoint, it's the ghost UAV that lines up with the waypoint instead of the actual UAV. We did the same thing here at Texas Memorial Stadium by making our UAV think that it was rising upward at a fast clip. And you'll see here that in response, it falls downward. We can go ahead and roll it. The bar at the bottom will tell you who's in control. At first, it's the authentic signals and the ground controller who's in control of this UAV. But at this point, when they go red, it's now the spoofer, the hijacker, who controls the UAV, and you'll see that it drops precipitously toward the ground. That's all under control of this remote hijacker. Then at White Sands, we were invited by the Department of Homeland Security, or authorized by the Department of Homeland Security, and in fact they facilitated some of this test, so that we could conduct a test over the air, where we capture the UAV in mid-air. We did it from about a half-mile away. On a hilltop, we broadcast our signals. You can go ahead and roll it now. And you'll see that in this case, as in the former case, the UAV started in a nice hovering position, but then came straight down as if it were an elevator moving down a shaft, entirely under control of the remote hacker. So, what are the implications for our national airspace? Well, back in February, Congress handed a mandate to the Federal Aviation Administration to develop a comprehensive plan for safely accelerating the integration of civil UAVs into the national airspace system. And I believe that the results of our demonstration should factor heavily into that plan. But the truth is that the FAA its culture and its expertise is geared more towards safety than security. And our test implicated the security of the airspace. So I think it's fair to say that the DHS may have also a role to play in drawing up these new rules and regulations. And I'm happy to entertain questions from the committee.